Okay, the last part of Unit 1 is doing 1.5 dilation notes. Today we'll do 1.5, we'll do some vocabulary words, and then we'll get into some examples and what exactly dilation does for your transformation. Okay, so let's start with some vocabulary. Let's start with the first one, which is dilation. A dilation is a transformation that changes the size of a figure, but not the shape. So the first blank should be size. And then the other blank is going to be shape. Okay, so what's going to happen here, we're going to be making figures bigger or smaller depending on the type of transformation that we have for that example. Okay, so figures are getting bigger, figures are getting smaller. All right, another definition, the center of dilation is a fixed point in the plane about which all of the points are expanded or reduced. When I tell you what is the center of dilation, and obviously we have a dilation problem, you are going to say it's 0, 0. It's a point. The center of dilation is a point 0, 0. It's the origin, okay? So your answer, if I ask for the center of dilation, is 0, 0. It's a point 0, 0. All right, the next definition, the scale factor. The scale factor is the ratio of the distances from the center of dilation to an image point and its pre-image point. All right, the scale factor is what we're going to be sometimes looking for in this topic of transformations for dilations. Okay, so I may tell you what kind of dilation it is, and I'm asking you, can you give me the scale factor? So I may give you the visual of it, and I'll ask you, what is the scale factor, okay? And we'll do an example here in the bottom, how to find that scale factor. And there's like a little formula that I'll kind of show you how to get for that. Okay, hoy hacemos 1.5 que son dilataciones. Es la última transformación que vamos a hablar antes de que empiecen su proyecto en unos días. Mi primera definición es dilatación. ¿Qué quiere decir eso? Lo que va a estar pasando es que van a transformar figuras más grandes o más pequeñas. So van a ser las figuras originales o van a estar más grandes o más pequeñas. Depende de la situación, del ejemplo. Okay, so esa es la primera definición, que el tamaño es lo que está cambiando en la figura. Cuando yo les pregunte cuál es el centro de dilatación de cualquier problema que hagamos en dilation, va a ser 0,0. Es un punto 0,0. Esa debe de ser siempre su respuesta. Okay, cuando les pregunto por el center of dilation. Ok, so hay dos palabras que van a decir dilation, reducido, reduced, o expanded, que se está enlargando, enlargement, también es otra palabra que se puede usar para decir enlargamiento, se está haciendo la figura más grande. Si dice reduced, que se redució la figura, es que se hizo más pequeña. Ok. The scale factor, el factor de el problema viene de buscando el patrón entre ciertas distancias. So, ¿qué es lo que va a pasar? Yo les voy a enseñar una fórmula que van a poder usar para buscar el factor. Okay? So, yo si les pregunto por el scale factor, hay una fórmula y es la fórmula que ven aquí, que estoy subrayando, ¿ok? Esa es la fórmula que vamos a usar, ¿ok? So vamos a ver un ejemplo para más o menos saber cómo buscar el scale factor. All right, So something important about the scale factor is if you see me put SF, so if you see me put SF, it means scale factor, okay? Okay, so just keep that in mind. SF is scale factor. Now, we have, and let's just concentrate on this first part right here. Okay, let's just look at that first. I have, let's say, an old triangle. This is my original triangle, and this is my new triangle. What I'm going to say is that maybe this side of my triangle, of my old triangle, is a size of a 5 for the length. And this new side of my triangle, which is corresponding to the old one, is 10. So knowing some of the sides of your triangle will help you find the scale factor. Okay, so how do we find this scale factor? Well, we have to do our new side over the old side. So my scale factor, and let me just go back and write SF. My scale factor, I need to do new, which is N, over old. Okay, and so let's do that right here. So what's the side with the new figure? It's 10, okay? So I'm going to put 10 at the top, not 5. I'll put 10. I'm going to be putting 5 in the bottom. Okay, so 10 at the top, 5 in the bottom, because it's new over old. All right, when I go to my calculator, and I'm going to go to decimals. That's the calculator I have access to. I'm going to do 10 divided by 5. And I get an answer of 2. All right. So my answer equals 2. So the scale factor is 2 in this case. Okay. Another thing I'm going to mention here is because it went from a small triangle to a big triangle, this is called an enlargement. And in the figure at the bottom here that I'm boxing in black, I have my old triangle, which is a big triangle, and then it got smaller from my new one. So it got smaller. This is called a reduction. Ok, so para encontrar el scale factor, el factor, usé la fórmula nuevo sobre viejo. So yo estoy viendo los lados del triángulo. Uno de los lados del triángulo original es 5 y el otro lado del triángulo nuevo es 10. So yo puse mi lado nuevo sobre mi lado viejo. Por eso el 10 va arriba y el 5 abajo en mi división. So 10 es dividido entre 5. Lo puse en mi calculadora, agarré un 2. So, mi factor es 2. So, mis triángulos, mi triángulo nuevo se hizo más grande por un factor de 2. Eso se dilató por 2. Como se hizo la figura más grande, esto se llama enlargement, enlargamiento. Cuando la figura se hace más pequeña, empezó como un triángulo grande, se hizo pequeño, es una reducción. All right, something that I'm going to mention really quickly here for the notation is, I know it's a dilation because I have that big D, and right next to the D, you're going to have a number that's going to be your scale factor. Okay, so that number right there, that'll be your scale factor. Algo muy importante que voy a mencionar es la notación. Como sé que tengo una dilatación, vas a ver esa letra D mayúscula. Y al ladito de la D va a haber un número. Ese número es tu factor, es tu scale factor. Lo que vas a estar haciendo, lo que vas a ver es que vamos a estar multiplicando el scale factor por los puntos que tienes, ¿ok? Muchas de las veces multiplicas, hay unas veces que puedes dividir. So, van a ver en las notas que va a haber un problema donde yo divido en vez de que multiplique, ¿ok? All right, let's keep going. The last parts of the vocab. So we're going to have a reduction or an enlargement like we talked about earlier. And A reduction is a dilation that has a scale factor between 0 and 1. Okay, so this is my old and this is my new. It got smaller. An enlargement is a reduction that has a scale factor greater than 1. So it started out small and it got big. Ok, so en la definición de una reducción, algo específicamente que están mencionando es que el factor para un problema de reducción siempre está entre 0 y 1. So es como una fracción, so como 1 sobre 2, 1 sobre 3, 1 sobre 4, etcétera, etcétera. En enlargement, un alargamiento es un factor donde está más grande que 1. So puede ser como 2 o 3 o 4 o lo que siga. Pero tiene que ser más grande que 1 para decir que esto es un alargamiento. Okay, so something quickly. You know it's a reduction if you have a fraction, okay? But it has to be between 0 and 1, okay, for it to be called a reduction. If it's a fraction, most likely than not, it's a reduction. If you have an enlargement, it's because your scale factor is greater than 1. Some examples that I put there were 2, 3, 4, could be 5, 6, anything bigger than 1, technically. All right. And then we start with some examples that are going to help us do what we need to do, okay? So here it says, given the dilation D, you have an original triangle and a new triangle here. So it's kind of hard to see, but you have your original triangle within the new triangle. So let's look at it carefully. So the one that I'm going to highlight in, so give me a moment, in red, this is your original. How do I know it's the original? So this part over here that I'm putting this point is my point X, okay? XRT. And because it doesn't have those primes, it means this is the original. This is the old. The bigger triangle, the one I'm going to put in blue, it went from X prime, R prime to T prime. And I need my blue highlighter. From here to here to here. This whole big triangle, this is going to be your new figure. Okay, so what are they asking? Let's look. Is this a dilation or an enlargement? Well, it went from old, which is a small triangle, to the new one, which is a big triangle. So because it got big, this is called an enlargement. So pretty basic question. Based on your figures, is it a reduction? Did it get smaller? Or is it an enlargement where it got bigger? It clearly got bigger. It started small, it got bigger. Again, how do I know which one's which? The primes, okay? If you've forgotten what the primes are, let me point them out. They're right there. It's those apostrophes that you see there. That tells you new image. What is the scale factor N of the dilation? If we're looking for the scale factor, I'm going to start with my formula. Scale factor SF equals new N over old O. So I'm going to recreate this fraction. So I'm going to put the new over the old. Now let's look at what was given to us. For my new triangle, it's the big triangle. So let's look. We're going to have to fill that in first. For my new triangle, it goes from X prime to T prime. They only give us information on this particular side, okay? We only have numbers there. So to find how much it was from X prime to T prime, so what I'm kind of highlighting here in my red part here, I'm going to have to add. So this part from x prime to t, this is 4, and then the rest is 8. So if I want to find the whole thing, so if I want to find from here to here, okay, what am I going to do? I'm going to have to grab 4 and then add it with 8 to get a total of 12. Okay, so the new side, that big side, x prime to t prime, that is going to be 12, okay? And let's kind of move this out here like this. It's going to be 12, so I'm going to put 12 at the top. Okay, and I need my old side. Okay, so let's look at the old side. So my small triangle, the old side is from x to t. So right here, when I'm putting in red, this is the small corresponding side to x prime t prime. So I'm going to say that this is 4 because that's what it says right there. That particular small part of your triangle is 4. So I'm going to say 4 here. So 12 divide 4, you can go to your calculator and put that in there, a division of 12 over 4. It should give you 3 when you put it in your calculator. Ok, para esta parte nos hicieron una pregunta básica primero, por ejemplo, 1, si es un enlargamiento, una reducción. So yo tengo que buscar en mi figura cuál es la figura original y cuál es la nueva. Yo siempre me muevo de la original hacia la nueva figura. Soy yo, cuando descifré cuál era la nueva y cuál era la vieja, yo vi que para irme de la figura original, que era más pequeña, se hizo más grande para la nueva. So, es un enlargamiento. La figura se hizo más grande. Yo sabía que la figura más grande era la nueva porque yo veo esos apóstrofes, esos primes para las letras. X prime, T prime, R prime. Veo esas apóstrofes, ¿ok? Eso me dice nueva figura. So yo por eso supe que se hizo más grande la figura. Ok, otra pregunta. What is the scale factor? ¿Cuál es el factor? Acuérdense que la fórmula dice nueva sobre vieja, new over old. Okay. So yo puse 12 arriba y 4 abajo. ¿Cómo busqué 12? Yo sé que 12 es el lado más grande del triángulo porque se mueve de X prime a T prime. So yo quiero todo ese lado. Okay, so yo sé que una parte de ese lado es 4 y la otra parte es 8. Las agregué para buscar la totalidad de ese lado, que era 12. En la figura pequeña, en el triángulo pequeño, ese mismo lado que está correspondiendo X y T, de X a T, del triángulo pequeño, nos dice que es 4. ¿Okay? Entonces, por eso el 4 iba abajo y el 12 va arriba. Cuando hice esta división, 12 entre 4, en mi calculadora me dio 3. All right, let's keep going. Let's do more examples here. It says, example 2. Given triangle PCG, graph below, given the dilation rule in D2, the triangle PCG. Okay, so there's something important that was given here. My dilation in the scale factor. That 2 that you see right next to D, that is your scale factor. So I'm going to write SF for scale factor. And I'm going to put it equals to 2. So right there, right beneath that big D, it tells me my scale factor is 2. There is several questions like, where is the center of dilation? Regardless of knowing the scale factor or knowing what type of graph they're giving you, you know what the center of dilation is. I told you earlier at the beginning of the notes, the center of dilation is always 0, 0. What is the scale factor? Well, we looked for it and we saw it earlier in our example. So SF, the scale factor, equals 2. Is this an enlargement or reduction? Well, because the scale factor is greater than 1, it's actually 2. This is an enlargement. Okay. Before I move on to C, let me just give some quick explanations in Spanish. Antes de hacer parte C de problema 2, vamos a hablar de las preguntas que tenemos para parte A y parte B. En ejemplo 2, vamos a tener una figura original, que es la que tenemos en el gráfico, y vamos a crear una figura nueva en unos momentos, y nos dijeron que la regla es que tiene una dilatación con 2. Ese 2 que está al ladito de ese D, de esa letra D, quiere decir que el scale factor es 2, ¿ok? Entonces nos hicieron la pregunta, ¿cuál es el centro de dilatación? Acuérdense que siempre es 0, 0. También nos preguntaron que cuál es el scale factor. Y ya lo habíamos visto en la regla, nos lo dieron. El scale factor es 2. Nos preguntaron si es un enlargamiento o una reducción, porque el scale factor es más grande que 1, porque el factor es más grande que 1, en este caso es 2, esto es considerado un enlargamiento. Okay, let's do part C. It says find the vertices of the image, triangle P prime, Z prime, G prime, and then graph them on the graph above. Okay, so they're giving us the original G, the original P, and the original Z. They're all given to us. This is all the old points. We need to get the new points, the image points. So we're trying to get G prime, P prime, Z prime, so we can graph it in our graphing calculator. We can graph it in our graph. Now, we do know that it has a scale factor of 2, right? Scale factor equals 2. So because it has a scale factor of 2, what I'm going to do is graph the original points and use the scale factor and multiply, okay, all of the parts of my point by 2 to get my new points, okay? So I'm going to graph 0, comma, negative 2, and I'm going to multiply by 2. And that will give me my new G prime point, okay? Let's go to our calculator. I'll use my Desmos calculator and try to do some math here. It says 0 and negative 2 have to be multiplied by 2, and that's going to give me my new values for my point. So let's do 0 times 2 and see what I get. 0 times 2. Okay, I get 0. Okay, so my first part is going to be 0. It says do negative 2 and multiply by 2. So let's go to Desmos, and let's do negative 2 times 2. Oop, let me just clear everything in here. Negative 2 times 2. Sorry, my pencil is a little weird sometimes. There we go. And I get negative 4. Okay, so I'm going to put that it's negative 4. So I'm just multiplying each part of my point by 2 to get my new point. 0, comma, negative 4. I'm going to do the same thing for P and for Z. I'm going to use my calculator, multiply by 2 each part, and get my answer. Okay, so then this point gets multiplied by 2, so does this point right there. Okay, so 2 times 2 is 4. 2 times negative 1 is going to be negative 2. If you don't know, put it in your calculator. Okay, Z, use your calculator as well if you need to, but do negative 2 times 2 and it'll give you negative 4. 1 times 2, and then it's going to give you 2. Use your calculator, please, as much as you can. That's why it's there. All right. So our next part is to actually graph this in our graphing part of our page. So I'm gonna go up here. the points that I got, the new points, I'm going to graph them in my graphing paper here. So I'm going to graph G prime first, 0, comma, -4. And I'm going to label it G prime. 4, -2. I have to find 4, then go down 2. And this is P prime. And then the last one, -4, 2. And I have to go up 2 right there. And this is Z prime. And I'm going to make this connection. Okay. So I have my old and I have my new one. Okay, so para esta última parte, como yo sé que el scale factor es 2, para sacar los nuevos puntos G prime, B prime y C prime, para agarrar los nuevos puntos, tuve que multiplicar los puntos originales por 2, porque el scale factor es 2. Ok, y pues multipliqué por 2 mi punto G. So 0 por 2 se queda 0 para mi nuevo punto. Hice -2 por 2 en mi calculadora y agarré -4. So cada parte del punto lo estoy multiplicando por 2 para agarrar mi nuevo punto. Hice lo mismo para P y para C. Usen su calculadora lo más que puedan, por favor, porque pueden hacer un pequeño error en cualquier parte. La última cosa que hice fue poner sus nuevos puntos en mi gráfico. Y puse G prime, P prime, Z prime. Obviamente el triángulo más grande, el rojo, es la nueva figura que se creó con esta dilatación de 2. Alright, so this is example 2. Let's go to the next page. I'm only going to do one of the problems here. I'm going to skip this one and going to see. Now, it says example 3. Given triangle ABC and it's graphed here, given the dilation rule D1/2, find the vertices of the image A prime, B prime, C prime, and then graph. Okay, so they want us to graph the new points. And what was given to us was this rule right here, D1/2. So what does that mean? My scale factor equals 1/2. Now, because I know that my scale factor is less than 1, it's a fraction, I know this is a reduction. So what's going to happen is my image is going to get smaller. Okay, so keep that in mind. I know it's a reduction because of the scale factor. I need to write my original points and my new points. I'll get them once I do my scale factor of 1/2. So looking at the graph, okay, let's start with A. Looking at the graph, the one I'm putting here in red, this is my original A. So A is in 1, 2, 2,4, because it goes up to 4, because this is 4 right there. So 2,4. This is my point A. What about B? Well, if we look at B, it's after 5, so it starts at 6 for my X value for B. How much does it go up? It goes up to 2. So I'm going to go and say this is 6,2 for B. All right, our last point here for the original. So this is the old triangle. It starts at 10 for the x-axis, and then it goes up to 6. Okay, so I'm just grabbing my points, giving the coordinate points here. Nothing crazy. Okay, so these are my original points, the pre-images. So this is my original points. I'm going to get the new ones. And I know my scale factor is 1/2. So I'm just going to rewrite it here. I know my scale factor is 1/2. Now, instead of grabbing everything and multiplying it by 1/2, we can do that if we needed to. Okay, that's also correct. What I'm going to be doing is grabbing each of the points, and instead of multiplying by 1/2, because this is a reduction, and only because it's a reduction and it's a fraction, I can do this part that I'm going to do. Okay, what I'm going to do is think about this as dividing instead of multiplying because it's a reduction. You can only do this when you have a reduction. Okay, so instead of multiplying by 1/2, so I could do, these are my options. I could grab each point and multiply. by 1/2. But it's kind of tricky to multiply by 1/2. You do it with your calculator, but the easiest way to think about this is instead of multiplying, because it's a reduction, again, it has to be a reduction to do this. I'm going to say, well, let me divide. And what I'm going to do is divide by the number at the bottom of my fraction. I'm going to divide by 2, each part of my point. Okay? So I'm going to pick this one. When I have reduction in hand, you're going to see me think about it as I'm going to divide every part in my point by that certain number, the number in the denominator in your fraction. So what I'm going to do is say, well, let's divide it by 2. Divide by 2 this one, and I'll divide this one by 2 as well. If I multiply by 1/2, I'll get the same thing, okay? But I want to show you that there's another way that you can think about it too. If it's a reduction, if you are working with a scale factor of a fraction, divide by 1/2. You can divide, okay, by whatever the denominator is. In this case, it's 2. Okay, so let's do some division here. Use your graphing calculator. I'll use Desmos. Okay, so it says to do 2 divide by 2. So I'm going to grab 2 and I'm going to divide it by 2. And my answer is 1. So my x value for a prime is 1. So let's write that down. It's 1. Okay, so I'll do the same thing here. I'm going to do 4. And I'll divide it by 2 and get my answer. And I get 2. Okay, so this is 2. So 1 comma 2 is my a prime. So I'm going to keep going. I should be doing the same thing for every part. I need to get b prime. So I'll do 6 divide by 2. 6 divide 2. And I get 3. All right, let's keep going. I'm going to do 2 divide 2 and see what I get. And I get 1. Okay. So 3 comma 1 is my b prime. Let's do c for our last part here. So it's 10 divide 2. If I use my Desmos, I know it's going to be let me just move this a little bit more to the top. Oops. There we go. Then just grab what I need. 10. Oh, come on. 10 divide 2. 5. Okay, and I'm going to do the other division just in case I'm having trouble again using Desmos. Let's do 6 divide 2, and I get 3. So it's 5 comma 3 for my point here. 5 comma 3. Okay, all I need to do now is just put this in my graph here. A prime 1 comma 2. So 1 comma 2. And let me just use another color just so it's a little bit clearer on which one is which. So 1 2 1, and I went up to here, right here. A prime 3 1. This is 3, and I'm gonna go up 1. This is b prime. Okay, and then the last one, 5 3. I have 5, and I'm gonna go up to 3, just right there. And this is c prime. It kind of goes inside of the original. That's okay. And then this just connect all of the points. So we have the original, which is the one in black and with the sides in black, and then we have our blue one, which is our new triangle. All right, you should have homework in Ok, para esta última parte de las notas, eh, lo que estamos haciendo ahora es un problema de reducción. Yo vi que mi regla es que tiene un scale factor de 1/2, o el factor es 1/2. Yo sé que es un problema de reducción porque el factor es menos que 1, ¿ok? Es 1/2, es una fracción, ¿ok? Igual que le hice en el problema anterior, voy a agarrar todos los puntos y una de mis opciones es multiplicar por 1/2. Puedo hacer eso, multiplicar por 1/2, lo que sea el scale factor. Mi otra opción, y fue la opción que hice aquí para mi problema, es dividir, y puedo dividir por 2, ¿ok? ¿Por qué por 2? Cuando tú tienes una reducción, ¿ok? Es la única forma que puedes hacer esta división, ¿ok? Si tienes tú un problema que es una reducción porque tienes una fracción como el scale factor, tú puedes, si quieres, dividir. Solamente si tienes una reducción puedes hacer esta división, ¿ok? So, puedes dividir por el número que está abajo en la fracción. Y el número que está abajo en la fracción es 2, el denominator, ¿ok? So, yo, en vez de multiplicar por 1/2, yo decidí que voy a dividir por 2. ¿Ok? So, agarré cada punto y cada parte del punto la dividí por 2. ¿Ok? 2 entre 2 es 1. 4 entre 2 es 2. Usé mi calculadora para que me ayudara también. 6 entre 2 es 3. So, estoy haciendo una división. ¿Ok? Estoy dividiendo. Agarré mis puntos nuevos y aquí en mi figura agarré los puntos nuevos que saqué con mi división y los puse en mi gráfico, ¿ok? Si tienes dificultad poner puntos en el gráfico, tienes que ir a tutoría, ¿ok? Porque vas a seguir haciéndolo en cada parte de Math Models. Ok, so mis puntos nuevos que puse en azul son mis puntos nuevos y es un triángulo más pequeño, ¿ok? Es una reducción. Tienen tarea. And also going to skip number 5. Okay, so that's what in quizzes or Wayground. Okay, so go ahead and start your homework. All right, good luck. Creo que es un quizzes or Wayground. Buena suerte.